Okay, we just want to go through the important factors for every single project that you ever do, and this doesn't change. It doesn't change whether you're doing bridges, storage tanks, ships, anything that's steel. These are the crucial steps you have to always do. Okay, where possible. Okay, the first thing you have to do is edge radius on new steel work. When you're doing old steel work, this is not so important because you can't access many of the edges. But edge radiusing on new steel is vital, because what happens is if you apply Zinga or paint onto a sharp edge, which is a 90-degree edge, as it dries, it pulls back from the corner. So if you're taking measurements, you'll be getting, say, 100 microns on the flat and on the flat, but on the corner, you're lucky to get 50 microns. So in America, this is one of the biggest causes of lawsuits, because people say, okay, we want a 20-year system or a 30-year system. And because they don't edge radius and do it correctly, the system may last only 12 years or 15 years. And then the guys who own the bridge say, well, we have to reblast this bridge. It's going to cost us 12 million. We're going to sue you for it, for the costs. So a small thing like this, I've seen it on ships and so on. It's a small thing, but it's so important. The second one is pre-cleaning of the steelwork, because any steelwork, especially near the coast. I mean, when I was in Takoradi with Philip a few years ago, the humidity there was really, really high. So that means there's a lot of chlorides in the atmosphere. So during the day, this salt is deposited onto the steelwork. During the day, and especially at night, when you have the winds blowing from the sea onto the land, it carries a lot of salt onto the steel inland, right up to about 10 kilometers. So pre-cleaning is normally at 150 bars to knock off all the salt that you can. And then after that, the blasting should remove the rest. Also, for things like this tank that you're looking at, this tank project at Unilever, all your bolted joints, if there's any oil or grease around the flanges when they were putting in the bolts, there could still be grease and oil present on the flanges. So that must all be taken off again with pressure washing. It's never ever good practice to use a rag and solvent or something, because all you're doing with oil, you're spreading it out. And even some guy said to me, look, we clean here, all the oil is gone. And I said, no, the oil's still there. You can't see it. You've diluted the oil. It's still there. And then when you're blasting, you're going to push the oil into the steelwork. And I'll take a white cloth, a new white cloth, and I'll rub on his clean area, and it comes off marked to say, there's your oil. It's always there. So oil removal, salt removal, and then any loose dust and atmospheric contamination. So the pre-cleaning is a very, very important step. You don't want to have any contamination being driven into the steelwork while you're blasting. The next phase is blast cleaning. And again, we always go for SA 2.5, which is the standard around the world for most people. But with Zinga, it's the depth. As we always recommend 50 to 70 microns. And I've got another slide, I'll show you why, but it's critical for a lot of blasting work. If you go too shallow, you lose your pull-off values. Okay, with Zinga on a correct blast profile, when you do a pull-off test after 7 days, you're up to 6.5 megapascal, which is very, very high adhesion. So and of course with high adhesion, you get better conductivity from the zinc, which gives you the voltage, which gives you your cathodic protection, and that protects the steelwork. So it all comes back to good blasting, good cleanliness, and the correct depth. The next stage is de-dusting. After all your blasting, if you don't de-dust properly, I've seen people spraying Zinga and paints onto a dust layer. So when it dries, it's drying on the dust. It's not actually on the metal. So straight away, it hasn't got a good solid grip, because it can become loose. It can even, in some cases, flake off if it's really a lot of dust. So de-dusting is always very, very important. In fact, in some areas inside tanks and that, or in tank outside tank where you have pipes, if you have some pipes joining together, and the same with if you have multiple welds, multiple beams coming together, and they call it a cluster weld. Same with pipes. If you blast clean that area, it's actually better often to take one of these small vacuum cleaners and just suck all the dust out. It's that important, because if you put in an air gun and you blow the dust out, the dust can go in the atmosphere and it'll settle again, and you won't always see it, but it'll resettle again. And if you do a tape test and hold it up, you'll see the dust is back. So on certain areas, you can blow it down, but on cluster areas or where you have a confined space, it's always better to vacuum the dust out. So those are the four main, the four main ones. The last one is flash rusting. Normally with paints and so on, you have to reblast the surfaces. With flash rusting, if you have light flash rust, which means you get little orange spots across the surface, you can still go ahead and apply the Zinga, because it'll penetrate the flash rust. It'll encapsulate it while it goes into the steelwork and grips it. So the flash rust is no problem at all, okay? That's one of the big differences between Zinga and paint. If you have a question, please let me know, okay? Okay, this is what I've just discussed. It's the first step, okay, but as I said, this is mainly for brand new steel. And it does have the same importance as when you're cleaning up welds, taking off a weld spatter. If you get any undercuts on the weld, you've got to fill it, get it all smooth, all before blasting. So this does have the same importance. And here you can see now, many steel companies around the world, and even one in Kenya, they're producing channels like this now, where your edges are already pre-radiused. So that saves you a lot of work. It's just the ends where you've cut the beam. You'll always have a sharp edge there. So if you just run a angle grinder, but not with a grinding stone, you'd rather use a sanding disc. So if you have like a P60 or a P36 disc, and just run it along just a couple of seconds and down the edges, and it'll immediately put a radius in there, and the radius will open up that sharp edge. So when you're blasting, it'll take a good blast. So this is unradiused. There's your sharp shoulder. When you blast cleaning, you see it splits the jet. So your blast is split. And you can profile the edges on either side, but you will not profile a sharp corner like that. So look what happens. It dries, and on the sharp corner, it's right down. And that area on the project, it will fail before all the other areas. Okay, with Zinga, you won't have the breakdown and then undercreep like you have with paint. But when the zinc wears down over time in that area, you may have a discoloration. It won't look nice. So it's best to have it the same thickness all the way around. See, now here you have an edge that's radiused, and you can see now that there's so much more area for the blasting abrasive to hit. There's no sharp edge. So you've opened out the corners, which is a very important aspect. And there you look now, you've got a consistent thickness all the way around. So if you've given your customer a 20-year guarantee or 30-year guarantee, by doing this, it will live up to that 20 or 30-year guarantee, and your customer will be very happy. And here again is other examples of radius beams, and you can see the one on the left. It's completely radiused all the way around, and on the outside as well. The T-piece, each flange sticking out is radiused, so that saves a lot of work. In cases like this, it's a good pre-clean, degrease, pre-clean, and then blast clean. It saves you many hours on a big job. It's so critical. You even have inspectors who come along and they have a gauge, and they can measure the corners. Okay, they wouldn't normally fail a beam for that, unless he's a really mean inspector. But normally they'll say, look, it's a little a little bit sharpish, can you just re-round it again with your sanding disc, and you'll check again, and you'll pass it. So they do have these actual metal gauges to check. That's how critical it can be. Okay, so thin coatings are much weaker than thick coatings. So if you have a job where you're using a paint top coat, thin paints, even though they're fully cured, if you're near the coast and you have salt water sitting on a thin paint coating, the salt carries an electric charge, okay, believe it or not, and it can pass through the coating underneath. With a Zinga, it's not a problem, but if you have a coating on steel, it'll pass. The charge from the salt water will pass through a completely closed coating with no defects, no pinholes. It'll pass through that coating to the steel underneath and start a little corrosion cell underneath. Then the next thing, you got blisters coming. So it's very, very critical. Okay, this is the pre-clean. We'll go over the pre-cleaning here. Okay, if there's new steel in the factory, people are handling. They've always got dirty gloves. Your slings on the cranes to pick up bundles of steel. The slings are always dirty with oil. Your fork truck tines, when the fork truck comes to lift them, they all can also have dirt. So oil and contamination comes from so many different sources. And of course, in many companies too, the actual rolling machines and so on, or bending machines, they can put oil also onto the metal. So the degreasing and pre-cleaning is a very, very important stage as well. Again, it's salts left behind. They can go into the surface. Okay, the top one, out of all the pre-cleaning methods, the top one is steam cleaning, always. I think there's a separate, there is a separate slide for this one. So your top one is steam cleaning. Your second one is using detergent. Your next one is high pressure, which is very expensive because 700 bar machines are not cheap to rent. And the last one is the solvent, which is one of the worst, believe it or not. So for steam cleaning, it's very fast, very efficient, and more companies around the world are now producing steam cleaners, which are very, very well priced. And they're nothing like the old days. You can get very good steam cleaners for $200 or $300. And when you're steam cleaning, the steam heats up the metal. All oil and grease gets heated and it runs down the metal. And you always work top to bottom. And the steam pressure is pushing all the contamination off the metal and onto the floor. You don't touch it with your hands or with a cloth, nothing. It's pure pressure. Does all the cleaning. And it's very, very fast, very fast. And in 1 hour, you can probably do 40, 50 square meters thoroughly. Your second one is detergent washing. So if you don't have access to a steam machine, most people will have a water blaster that can do 150 bars. So if you get strong detergent, it's very, very similar to the stuff you use at home for washing dishes and taking oil off your plates and stuff. All detergents work the same. So if you have an oily surface and you can rub it in with a cloth or even with a big brush, one of these stiff bristle brushes, you can rub the detergent in, leave it for a little bit, okay, and oil and grease will float up to the surface of the detergent. Then you come along with your water blast, and again the water pressure is pushing everything off the metal. So again, you're not wiping with a cloth, you're not touching the metal, okay. You only touch it when you're brushing on the detergent, but you're removing it with water pressure. So when that comes off and onto the floor, your metal is spotlessly clean, ready for blasting. That's a guy doing a rinse off on a tank, and all the oil's falling on the floor. High pressure washing, okay, you need a really big machine for that because you're talking a lot of pressure there. It's minimum 10,000 psi, but again, on this one you do not need to use detergent. Some guys do, some don't. But again, it's pretty fast. 700 bars, 10,000 psi. You can blast off a lot of contamination very, very fast. Some guys increase the pressure to 1,000 bars, so they can really, really move very, very fast through the job. And again, is the pushing action of the water jet that is pushing everything off the metal. That's showing you the high pressure. That nozzle, it spins and on the end, and as the nozzle's spinning, it's accelerating the water speed even faster. So it's coming out there about 1,000 kilometers an hour. And that's what's giving that pneumatic pressure, is pushing everything off the surface. You can go right up to 2,700 bars with this. So on some jobs, especially near the coast, if you're doing jetties in the sea and so on, this is the best method, because this method, it blows off barnacles, shellfish, old scale, oil, everything. It takes it all off in one go. So this is by far the best before you do sandblasting or blast cleaning. This is one of the best for all marine work. It's exceptionally good. You can see there all the shellfish on these on the steel work here at low tide. It'll take off all that, all the loose rust and all the mill scale will be completely removed, ready for blast cleaning. And these are your different definitions. But again, if you want these, please let me know, and I will email you the whole PowerPoint so you can go through it at your leisure. And if you have any questions to ask on this, you can phone or email, and I will give you all the answers. But this is the definition, okay? So when you are below 700 bars, it's water blasting. When you go above 700 bars, it's water jetting. Okay, and the water jetting associations around the world, this is what they use. So that's why we say water blasting with detergents. So you're below 700 bars, and normally it's 140, 150 bars of pressure. So this is the chart. But as I said, I'll send you all this information after this seminar here. Now this is a thing here where you come across in some old jobs, some old structures to be blast cleaned for Zinga. Jobs like this do not need to be degreased, okay? Because all you're doing is, if you put detergents and things onto this sort of surface, rust is porous, so it'll absorb it. So you actually have more things to remove. So it's better to, if it's completely rusted and you scrape it with a knife and it's all powdery, it's best to go straight in there and just blast clean, straight off. No messing around with pre-cleaning. Okay, I've seen this many times over. I've been doing this now for 47 years, and there's no point to waste time and money pre-cleaning rusted metal like this. But again, I said, if you have a knife blade or a wire brush, you just give it a quick scuff up and down, and if it comes off as dust, you go straight in and blast. Okay, no pre-cleaning. Okay, we come to blast cleaning now, which is one of the keys. Okay, bad blast cleaning, it can make or break any project. So it's an important step in those first four that we described. It's a very important one. The correct profiles will always ensure that you have the maximum adhesion values of the zinc. And just in case you don't know, when you apply Zinga onto a good blast profile, after 7 days, you will have roughly about 6.4 megapascal of adhesion strength. After 3 or 4 months, it goes up to 9 megapascal. And after 1 year, it goes up to 11. So it's getting tougher and tougher with age. And it reaches 11 megapascal after roughly a year. And that remains constant. We did a pull-off check a couple of years ago in Norway, and the bridge was 30 years coated with Zinga, and the pull-off value was still 11.3 megapascal. So the blast cleaning done originally 30 years ago was very good. So this is a fantastic reference. Also, when you have the correct profiles, 50 to 70, or even a little bit deeper for marine work, you have, if you have the zinc that goes into a deep profile, if you have any impact on the zinc, it's actually pushing it inside the profile. It'll never crack or split. Epoxy zinc paints will crack, they will split and flake. But because Zinga is very compressible, and especially on a good profile, you can hit it with a hammer, literally with a hammer. I used to do demonstrations and hit it as hard as I could. And people were amazed. The zinc would never, ever crack. And it's all down to the good profiling when you're blasting. And again, if you had the right blast pressure, you're using the correct grit, like Black Beauty that we used on Akosombo, you'll always get a perfect profile every time. So it's not a problem. On new structures, the correct profile with the Zinga on, you'll get a slip coefficient of 0.52. Internationally, around the world, the slip coefficient on coatings, it has to be minimum 0.5. Because if you're building a bridge or a big tall structure like a power station or something, if you use bolts, nuts and bolts to put all the beams together, the 0.52 means that if that structure moves from earth movement or traffic or whatever, those bolts and nuts will never ever shift. Okay. If you use hot dip galvanizing, your slip coefficient is only 0.31. So that means under movement, those bolts can move on the shiny zinc galvanizing. So with Zinga at 0.52 slip coefficient, your bolts are going to remain locked forever. They'll never ever move. So that structure is structurally sound compared to a hot dip galvanized structure. It's a big point that. And again, if you guys have any questions on this at any time, please. If you don't want to ask today, but once you've had a chance to go through this PowerPoint at your own leisure, any questions on this, please ask, and I can send you a full explanation on all these points, because they are critical. And this is one fight you will have against guys doing hot dip galvanizing on structures. Slip coefficients are bad. And to compete, they have to blast clean. They've got to galvanize it with the hot dip galv, and then give it a blast to roughen it on the surface, which is very expensive. Whereas with Zinga, you blast and go straight on with the Zinga, and you've got your slip coefficient. So we have different methods of blasting. We did grit blasting in Akosombo and other projects. And vapor blasting is only a fairly new concept. It's only been out a few years now, about 7 years. And one of the big, very, very important factors on vapor blasting is that you use the same blast pressure, you use the same grit, but because the metering valves on these machines is different, and the machines are virtually the same price as normal blasting pots, but with a vapor blast, for example, we had a guy who was going to do a bridge about 18 months ago, and I said to him, "You should vapor blast it." He says, "No, we've been using normal grit blasting for many, many years." I said, "Okay, on this bridge, how much abrasive did you budget for?" And he said 120 tons. I said, if you vapor blast, you will not need more than 30 to 40 tons maximum. And I said to him, if you've already given your bid and they've accepted the bid, instead of dry blasting, you vapor blast, you're going to save yourself thousands and thousands of euros or dollars on that, because you only need 30 to 40% of the abrasive. And you'll do the same blasting speed, 12 to 14 square meters an hour on the same area at the same blast profile depth, but for only a fraction of the abrasives. So it's a big cost saving on using vapor blasting. Bristol blasting, using the small machines, they're mainly just for doing weld damages and so on. We have the automatic blast machines, but that's for doing, if you have a project where you have 300 beams, the automatic blasting machine will do that in a quarter of the time from manual blasting. And then the last one is vacuum blast. Again, like Bristol blasting, you can only treat 1 square meter per hour. So if you have a lot of square meters, you're going to be there for a few days doing small areas. So again, it's only for welds or areas around the flange. Maybe it's a critical area on a big tank or something. That's the only time you would use vacuum blasting or vapor blasting. So again, this is still normal abrasive blasting. This is the same all over the world. Okay, there's your work rate, 14 to 16 meters an hour. And you do have various blast medium. And again, we've dealt with the environmental protection agencies, in most countries now, you're not allowed to use slag like Black Beauty. You're not allowed to use it anywhere near water. So if you're blasting over a harbor or over a bridge or something, or a lake or a dam, they don't allow you to use slags normally. Some people still let it go, but in many countries, they insist you use garnet. Right. So that's your normal abrasive blasting there, as you've all seen. And this is the vapor blasting again. Dry blasting is now banned in most cities around the world. So if you vapor blast, it doesn't create a dust hazard. There's no dust clouds drifting around. And your blast pot, instead of having compressed air and abrasive, it's got compressed water and abrasive. So when the blaster pulls the trigger, you're getting the same blast, but you're getting water and abrasive, okay, not air and abrasive. So I think, and especially in Africa, where you have much more wide open spaces, many bridge projects and so on will still allow normal dry blasting. But I thought it's good for you to know that there is an alternative available if you ever needed it. And there's vapor blasting there. This guy is doing the side of a ship, and you can see he's not wearing a big heavy blasting suit. He's not wearing the hood with bulletproof glass. He's just wearing a pair of goggles, and he can blast. And you can see there's no dust around him, so it's always an option. And again, doing towers, they wouldn't allow you to do that in most countries. They don't allow you, especially where you have these power pylons are standing on farmland. They don't let you do dry blasting because there's dust everywhere. So here you can see vapor blasting. And again, this is just showing you the physics, how much cleaner a vapor blast can be as well. There's bristle blasting. Again, you're back to 1 square meters an hour. And there's a guy, he's working on a wind turbine. So they are good for working at height if you have to treat small weld areas. And I think I've got photographs of the, you can see that photograph showing the blast profile. It's very similar to that of normal blast cleaning, which you guys do. So yeah, if you have an area where it's not worth going on site with a big compressor and blasting equipment and hoses and all that, you can go on site with a bristle blaster and spend an hour here and there, and you can do all your small repair jobs on welds. And it's a very convenient way of blasting. Here again, we have the automatic machines. Again, this is all based on high volume steelwork. So I'll skip this for now because I wanted to get on to the other stuff that you guys are doing. There's your vacuum blast. You can see the small footprint. The footprint on a vacuum blast nozzle is probably about 125 millimeters. So it's very small. So again, what he's doing there is completely wrong. You wouldn't be blasting a pipeline. You'd be blasting the weld on a pipeline. So it's only geared up for very small work. Sweep blasting. This is another technique. I don't think we get photographs of it. No, we don't. When you sweep blasting, when you have to repair old galvanizing on anything, towers and tanks, anything where they've been galvanized 40 years ago, 60 years ago, and around the world, there's literally hundreds of thousands of power pylons. These lines across the railways that carry the power lines for the train. There's hundreds of thousands of those galvanized structures beginning to get back down to bare metal because the zinc's worn away. So on a project like that, when you sweep blast, you don't blast at 6 bars. You reduce your blast pressure to 3 bars, and then you're sweeping from side to side fast. So all you're doing is breaking the surface to make it rough, but you're not removing the existing zinc that's still there because you want to retain that zinc. So you sweep blast and it's fast. It's 35 square meters an hour, which is double the normal blasting speed. Because you're sweeping so quick, it knocks everything off and then straight on with the Zinga, straight on. And that's it. It's there for the next 30, 40 years again. So you can re-galvanize things at a very high speed. So these are your cleaning rates. This is a summary. So the first two are the normal ones. And then, as I said, bristle blasting is very, very slow. Vacuum blasting, very, very slow. And your sweep blasting is very fast. Your blast profiles, okay, as I said, they're very, very important. Your SA 2.5 cleanliness, which you guys will have no problem with at all. The blast profile range, you won't have a problem with that because you're using the normal slag abrasives and so on. I just wanted to show you. Okay, that's a fantastic blast, especially up in the corners there. He's done a very good blast around all the rivet heads, the bolt heads. But I wanted to show you here, this is the blast profiles. Okay, so this is a normal blast profile, looking at it. It's 45 to 60 peaks per centimeter. And there you put your Zinga in, so you've got your layer, your DFT above the blast profile. This is one where somebody has put the blast pressure too high. He's come in and he's blasted it at about 7-8 bars of pressure, and the profile is the same depth, but your peak count is far too high. So there he's getting 70 to 90 peaks per centimeter instead of 45 to 60. And see what happens when you put a coating on, it goes halfway down, and because those blast profiles are so tight, your coating goes halfway down and starts drying from the heat of the sun, and it'll never go right down to the bottom of those profiles. So that again, you won't worry about this because you've had your blast spot set up. Your blasting has always been very, very good, but it's just make you aware that sometimes some guy will do something wrong, and not in your team, but if you see this, you can identify it immediately. So we like to make you aware of this. So I like to teach all of our guys all these small points. Again, with blasting, if you're blasting MIG welds, okay, as opposed to a stick weld, MIG welds, which are very, very common these days, are very hard, because when you're welding with the MIG welder, the wire coming out is very high in manganese, and it has to be because it's feeding off a reel. If it didn't have manganese in it, it'd be too soft, it would just buckle inside the machine. So when the weld cools down, it's very, very hard. So sometimes when you're blasting, you can't do your normal speed along. You might have to go a little bit slower on a weld, on a manganese weld, and you've still got a good profile. So as we said here, you can also use a closer standoff. So normally when you're blasting, your standoff distance is roughly 300 millimeters from the metal surface. Some guys go up to 400. So on certain welds, you can go much, much closer. You can close the gap and blast much, much closer, and you've still got a perfect profile on these sort of welds. So normally on some guys, they blast normal steel a little bit too close, and then your profiles go too deep. And what happens when they go too deep? You start spraying on the Zinga, and then suddenly after a couple of hours, you're using a lot of Zinga and you're running out. Because a blast profile, we had a guy who blast cleaned a fishing boat, and instead of blast profiling at 50 to 70, he was blast profiling 90 to 100. And to complete the DFTs of the whole boat, he had to buy another 150 kilograms of Zinga, just from that small profile difference. So it makes a big difference on your costing. Okay, here again, here's your abrasives. If you're working in an enclosed environment where you can recycle the grit, this chill down abrasive is the best in the world. It's always been excellent. You can recycle it 20, 30 times. This is a copper slag that you guys use all the time. So that's an excellent abrasive. This is garnet, which you would use over water. Unless your environmental protection guys are more lenient. Otherwise, they would insist on this. And this is to show you a profile taken from a computer. They have a piece of steel, and they scan it with a computer, and it generates this image. So you can see that along the edge of the sample there, you can see the sharp dips, and that's showing you how sharp your profiles are. This is why we say never ever use round shot when you're blasting, because it gives you that finish instead of a sharp tooth. And there, look at the profiles on the side. There's no sharpness to hold onto the coating. It's just all loose like a golf ball sort of profile. So that's absolutely useless for coatings. And this is your standards chart again, showing you the SSPC, the ISO, and so on. Again, you guys always work to SA 2.5, which is NACE 2. So if you have an inspector come along to a big project and he's a NACE inspector, he will be talking this language. He'll be saying, yeah, that's a NACE number 2 finish and so on. But they also know 2.5, so no worries there. Again, there's a difference. SA3 you'll only use if you're using aqua Zinga, okay, because that's you only need that cleanliness for a zinc silicate finish. Otherwise, all your work will be SA 2.5. And that's just your definitions. This is interesting now, to try and explain to people around the world about the importance of blast profiles. I've shown you there a normal corrugated tin roof, okay? You have a corrugated tin roof and you measure its, I've put on the wrong thing there. Sorry. That top one should be 1 meter. I don't know how I got 1.6. So if you have a corrugated tin roof section, it's 1 meter. If you pull it straight, it goes to 1.6 meters in a straight line. So that's how much surface area is actually coated on that roof. Now, if you do the same thing with the blast profile at 60 microns, if you have a 1 meter blast profile, if you could somehow pull it straight, it goes to 2.6 square meters. So if you have 1 square meter by 1 square meter on, say, on the side of a tank, like you're doing at Unilever, you're not actually coating 1 square meter, you're coating 7 square meters. And that's why you have such a high pull-off value when you're doing pull-off testing to see how strong the adhesion is. You're actually coating over 7 square meters. So when you're trying to pull it off, it's a lot more than you think. And this is one of the key points of the profile. That's why guys put a shallow profile. You don't have that depth and you don't have the same amount of linear coverage. So this is one thing. It's so important. And I thought this is a good example to show you everybody is how it's worked out. And just to show you that blast cleaning is a science. These are some of the diagrams that we've worked with over the years. There's more than this. So yeah, it's profiles are very scientific and for good reasons as well. Okay, dedusting. Again, you can make up your own dedusting kit. You just need to get some wide clear tape. I mean, they specify you've got to use a certain brand of 3M tape and all that, but that's just nonsense. I think it's just commercial. If you get any tape, okay, it's best to use 50 mil if you can get it. They call it packaging tape, but it's a clear sticky tape. If you can't get the 50 millimeter one, the normal 20 or 25 millimeter is fine. Okay, so after blasting, you dedust. After dedusting, you more or less lay your tape onto the surface of the blast and rub it. Okay, you can use your thumb. Some guys use a little cocktail stick, the little plastic stick with a ball on the end that they put on these fancy cocktails, and you can rub it with that and get it rubbed in very, very well. And then you can hold it up to the sun. Okay, sometimes depending on what sort of dust you're expecting, you can use a little piece of black cardboard and put the tape onto the cardboard, and immediately the dust is highlighted and you'll see it. If it's black dust from using slag abrasives, you can do the tape test and you put it onto a white cardboard and you'll immediately see how much dust is on that tape. Okay, and then all you do, okay, that's a tape there, and that's a magnifying glass. Again, it's part of a kit. And anything to do with coatings, as you'll know, is always expensive. And this little kit's like 400 euros, which is ridiculous. You can get a cheap magnifying glass online for about 10, 15 euros, a very good one. And as I said, you can use any tape. So and this is the instructions, okay, which you will get this, so you can read that. But what the main thing is, this little guide here. You can blow this, you can print this off and glue it onto a piece of cardboard, and then you can put your tape off after you've taken your tape reading and rubbed it. You can put it next to this on a cardboard, and you can see if it's a grade 1 or grade 2 and so on. You can see how much dust. Visually, you can see it immediately. Normally, we say dust grade 2 or below. If it's dust grade 3, you have to re-vacuum it or re-blow it. Okay, so the grades, again, this is for a very, very good reason. You don't want to apply any coating at all over dust, no coatings. So doing the de-dusting to ISO 8502 is very straightforward. I mean, when I have a chance, after COVID is finished, I will come and visit you guys, and we can go over all this again, physically together. But this is just to let you know for now that this is how it's done, and you guys can do it yourself. You don't need these fancy kits. I've told guys in the Philippines and South America, you don't have to buy these fancy kits. It's all commercial. You can make up your own kit, print off this scale, and this scale is used internationally, even by Alcometer and all the big companies who sell equipment. They use the same scale, so you could print that off and do your own thing, okay? So you can do your own de-dusting and your own measurements. Flash rusting. Okay, flash rusting occurs quick. So you might be blasting. I've seen it in Mombasa and Tokaradi. You blast clean. It's a very humid day. You have high humidity levels in the atmosphere. It can be up to over 80% some days. And then you see it's flash rusting. Little spots start appearing after 1 hour, 2 hours. And normally we say try to overcoat the metalwork within an hour if possible. If not possible, you just got to keep an eye on it. And if you see flash rusting occurring, then spray on the Zinga immediately, and then carry on with your other work, your other blasting work. But don't leave it, because you don't want to have to re-blast. Again, if you catch it at that point, it's still a light flash rust, which we call light. So there's no problem. It's when it becomes medium or heavy, then you've got to either water jet, not blast, water jet, or you got to re-blast. So again, you can, guys who do slurry blasting, they can have that problem even quicker on a hot day, because all the mist from the water can land on the metal that's been freshly cleaned. And again, if you have salt in the atmosphere, and it's quite, you won't believe this, because everybody blames sea salt in the atmosphere, but if you have normal salts like nitrates, you know, the air you breathe contains 20% nitrogen, so that dissolves in atmospheric moisture. So if you have a very humid day where your relative humidity is 80%, these salts can dissolve in that humidity and land on the metal and cause flash rusting. And that even on lower humidities, like nitrates, that can dissolve at 40 to 50%. It's only the salt from the sea will condense at higher humidities. So just keep an eye when you're blasting on a humid day near the coast. Always keep an eye on the metal after you've blasted. And while you're blasting, just keep watching the first pieces you've done. And if you see a little bit of orange gingering taking place, then quickly spray on 1 coat of Zinga, even a thin coat, even 30 microns, and that holds it. That'll hold the blast. Then carry on blasting, and then come back. And then when you finish all the blasting, you can just coat the whole lot at once and get your uniform DFT. So never let it flash rust beyond a certain point. And I'll show you here. Again, these are the various humidities where salts can attack the metal. But the main thing for you to know is there. That's light flash rust. So you can still look through. This is not a very good photograph, but in real life, when there's light flash rust over the metal, when you look through, you can still see the silver metal underneath. This is not a good photograph to show you, but it's one that's used by the navies and all this. So the second one is medium and the third is heavy. There's also, I think, there's a rub test, yeah. So that's light, medium, and heavy. If you're not sure of this, visually, you do a rub test with a white cloth. And this may sound very basic, but this is used by the American navies, the British navies, and other guys, because it's a very good indicator of just how bad the flash rusting is. If you rub off and you use this as your visual comparison, this photograph, which you can do. If you have a light flash rust, not a problem. At that point, spray on the Zinga. Again, if you've still got blasting to do, just spray on a very thin coat of Zinga, and that'll lock in the blast. It's secure and safe. It's not going to go anywhere, and carry on blasting. If it's moderate, you're going to have to maybe give it a sweep blast and knock off all the loose powder, but a very light sweep blast. Either that, or if you have access to the water jetting, you give it a 700 bar water jet, and that'll knock off the light rust particles. But this is a very good indicator. As I said, it's a very basic test, but it is used by many people around the world, and they've never had problems with it. So that is light, and we say you can put Zinga over light rust, and we say that in writing as well. So you're covered for that. Okay, this light, how to avoid it? Well, again, if you have two options here. If you're vapor blasting, you can use chloride, which is now made in Europe, so you can get it much easier. In the old days, it was made in America. It was much harder to get it imported, but now we can get it through Zinga and supply it to you guys along with your orders. When guys are vapor blasting, they actually put the chloride into the water inside the blast pot. But if you're not doing that, you can blast clean and then spray it on with a spray, the chloride, spray it over the metal, and that your blast will stay bright silver for about a day and a half, 2 days, even by the coast. So there is ways you can get around that. If you don't want to blast, put on some Zinga to hold it, which a lot of guys do anyway. But if you want to blast a whole lot and then put Zinga on, you can blast and spray on your chloride or your Holtite and carry on blasting. So you have options. It's a very, very flexible system, and it makes life easy as well for you guys. Okay, this is the end of the first webinar. I want to show you this project you're working on here. Can you see that photograph? Has it come up yet? So I can't hear you. There's a bit of distortion in there. Is this photograph come onto your screen okay?
Yeah.
It is, okay. I've just ringed off a few of the areas where you're going to really pay good attention. Is all these joints? Because again, you got welds. I don't know if they're MIG welds or stick welds, but all welded joints. And they're the areas where if they weren't painted, if you build a structure and you leave it for a month, the first areas to go is always the welds. They'll start rusting before any other part of that job, always, because you have different metals. You've got your metals welded together, which are the same metal, but the weld metal is different, and that's why you get a reaction, and it forms a little corrosion cell. It starts corroding. So they're the areas that always start corroding first. So these are also why these areas are critical. When you're blasting, you blast the structure as normal, but these areas you've got to pay a lot of attention to, all welded areas around flanges and so on, and also things like bolt heads. where they've bolted. You've got to blast all the way around and around the washers, everything, before you coat. So I've just ringed off some key areas. This takes a little time to load here. I don't know if these photographs are very clear for you. Is that okay on your screen?
Okay.
Yeah.
Okay. So again, I'm just highlighting the areas. You can see the bottom of the handrails on the tank where it's attached to the tank. And again, you have different metals on these areas between your flange of the pipe and the tank. And then the other one is your joints. So these are all the very critical areas. On the other photograph, it's showing you your valve. So obviously all around the flange, it's a critical area, because if that cracks and leaks, you're going to have big problems. So that's a critical area. And then you'll see the top one is where the two flanges bolt together. On any bolted joint on any structure, when you bolt two pieces of metal together, they call that a man-made crevice. And of course, crevice corrosion is one of the biggest corrosions in the world after general corrosion, because crevice corrosion, whether it's vertical or on its side, when you get rain, sea spray, overnight condensation, the water will sit on the outside of that joint. And because you have a crack, you have capillary action, and that capillary action inside the crack, there's a lower pressure, and it starts sucking in the water. And when it sucks in the water, it sucks in the salt. So you have very bad corrosion inside there. So when you're blasting these areas, if that valve is not going to be unbolted and taken apart, it's going to be left as is. When you're blasting, you've really got to focus inside the two plates where they bolt together. Put your blast nozzle inside there and hit the top and the bottom all the way around the whole flange. And you put the Zinga in there with a brush, okay? And normally with these sorts of things, I say you take a normal paintbrush and you cut off the last 20 millimeters off the brush. That makes the brush very stiff. So you dip it in the Zinga and you just ram it in. You know, you don't go all soft. You just even hold the brush this way and just ram it in there all the way around, and you force the Zinga inside there. And that changes all the dynamic inside that joint, and you'll never have crevice corrosion inside that joint. So crevices are a very, very critical area on all projects. So just remember, all bolted joints, first do the crevice, and then you go around and do all the nuts and bolts with the blasting, and then do the general flange areas as well. They're all very, very critical. And I'll just get the last one here. Has that come up on your screen?
Yeah.
It has. Okay, so what I've marked number one there. And before blasting, one of the teams have to come along with a chisel, one of these. They call it a bolster. A chisel and a hammer, and just chisel off all that cement lying there. So you're right back down to the smooth concrete of the plinth that the tank is sitting on. And once all that's gone, then you can blast clean, because with that there, if you start blast cleaning, you're going to be hitting up all that dust, all the concrete and cement, whatever that is. That's going to shatter and put dust everywhere. And of course, and with dust, when you get rain, the rain mixes with that dust and it makes it a very high pH dust. So you don't want that on metal when you're coating it. So that should all be chiseled clean, and then give it a scuff with a wire brush, and then blown off with your air gun. So all that's gone, all that not residue, all that debris that's lying on the concrete. So they must all be removed. then you can start blast cleaning. And again, this weld is okay. It's showing no corrosion on the weld, but the corrosion you can see where it shows you number 2. Tanks, storage tanks are like power pylons. They're always sitting on concrete normally. Okay, that's what makes them stable. So on pylons, it's called a muff, a concrete muff. Obviously, it's much smaller than this, but this plinth is the same thing. You have steel bolted onto the concrete, and when it rains, you have splashback. So the rain will come down, hit the concrete, and it splashes up. This is why you'll see on many pylons, the first 1 meter up from the ground or up from the concrete is always painted black. Normally our tar free, something like that. It should be the same thing on tanks. Okay, even the first 150 millimeter, you blast clean, put Zinga on, and then you put on the tar free, and that stops splashback going on there. Because what happens near the coast, you will have salt spray coming at night with the wind blowing. It deposits salt down there on the concrete and on the metal. Then during the day, the water evaporates. It leaves the salt behind. And the next day, more's coming. It evaporates and there's more salt. And the salt can sit there and maybe do no harm for a few months. Then it rains. When it rains, all that salt that's collected, it dissolves in the water and it starts attacking the steel. So I always tell the guys after blast cleaning, when you're applying a Zinga, you can apply it onto the metal and down onto the concrete as well, just for like 50 mil, and that seals the concrete and it seals the metal fantastically. And the same thing with your tar free, come down the metal and onto the concrete with the tar free, and that seals that whole area, because obviously that's a critical area. If you get pitting corrosion and it starts eating holes, whatever's inside the tank's going to start leaking out, and then you got one heck of a job. Because to weld that, you'd have to drain the tank, and then it's a big expense. So if you catch it at this stage, when you're doing a reblast and a recoat, you can get it done perfectly, and you'll have no problem at all that area. And it's the same on bridges. Even in Europe, I said to guys, when you have your stanchions are bolted into the concrete on the bridge that holds your crash barriers, your rails, I said when you're coating the Zinga and the top coat from the steel flange onto the concrete of the bridge, and same with your top coat as well, and it seals it, because and sometimes too you have salt sitting, it can migrate through the concrete and it attacks your bolts inside the concrete. And then okay, with a tank normally doesn't move unless it's being refilled, and it can move slightly. But a bridge can move every day because you have heavy traffic on it. But I say any metal that's bolted to any concrete, always assume it can move. So if you have salt going inside the concrete and attacking those bolts inside the concrete, any movement is going to stress, and those bolts are going to crack inside the concrete. And most of the time you won't see it until the damage starts showing above, and then your structure can move or distort. So these small things are so important in the long run, in the long term. It's very, very important. So that was just the main points I wanted to cover on this project. As Christian said, if I didn't have COVID over, then I could have come across to help you guys on the Unilever job. But at the moment, we're not allowed to fly from Europe. We're not even allowed to go on the aeroplane. So my hands are tied. So that's what I wanted to show you guys today. Let's take that down. Okay, there. So the sound isn't all that good on the on this thing, but if you have any other questions to ask today, and as soon as I finish here, I will email. I've got Lauren's email address, so I will send her this PowerPoint, and then she can share it with all you guys, and then you can go through it on your own, or you can go through it together, please. And if you have any questions, please feel free to ask. by phone or email or whatever. We're always here to help. The sound is very distorted.
Yeah, they were asking whether you would send us the whole profile. You will send me the whole profile.
The moisture. Yeah, you get moisture. You get moisture coming from the atmosphere every night. If you go outside and you feel your car is wet.
Okay, Rex, they were asking concerning about the profile, what we just talked about. They will need a copy, so they would go through it.
So
they will need a copy of the profile.
Yeah, sorry, what about the profile?
Yeah, they will need a copy of a profile. You send it to me, I'll give it to them.
I will send you the whole PowerPoint.
Yes, the PowerPoint.
Yeah, when we finish here, Laura, I will send you the whole PowerPoint, and then you can go over it together.
Okay. Thank you.
Yeah, because I do realize there's a lot of information to try and accept in a short space of time. It's a lot of information, but if you can go through it with the guys, with the team, and we'll answer all your questions, and then when you're ready, we'll go through webinar number 2, which is showing you how to mix the Zinga and dilute it, filter it, all that into the pressure pot.
Okay.
So you must just let me know if you want webinar number 2 this week, if you have opportunity.
Okay, I will let you know as soon as possible.
Yes, if you can.
Okay, Rex, please, Can you please go back to the 2 Unilever tanks that you explained for us? The tanks, the Unilever tanks, the pictures, they want to give them. Yeah.
Okay.
They need explanation about the valves on the tank.
Yeah, I'm just trying to find that one. No, I can't find it here. Damn it. That damn thing here.
You could still can't find.
Is it that one?
Yes.
Okay. They have a question?
They want you to take us through the same process again, concerning about the valve.
Okay.
The valve and the joints. They want to get a clear understanding about it.
Yeah, what the phalanges are.
So you have 2 flanges. Let me just, I'll use these plastic boxes here.
Okay.
So you have top flange and the bottom flange. Oh, where's it?
Is
that showing?
No.
That's strange.
No, it's not showing.
Oh, no, the camera's got a bit funny here. Okay, so you have the top flange and the bottom flange. and they come together, and you have bolts through it. But when you have a bolted joint, inside that joint, at the back of it, the pressure is always lower than on the outside. So when it gets wet from rain or sea spray or anything, that moisture is pulled inside between the two flanges, and that's how it starts corroding. That's why we're saying when you blast clean, if that's a two there, you blast clean. You point your nozzle in between the two flanges, it's up and down. So as you're going around, the blaster can go up and down between the two flanges, all the way around the whole flange. And then when he's done that, then blast the flat face, and then blast the top and bottom of the flange with the bolts, and then coat it. But first, when you coat the where they meet, I said you take a paintbrush and you cut off the last 20 millimeters, so the brush is short, and then you just put it into your Zinga, and then you just ram it in between these, just ram it in all the way around, and it forces it in, because the zinc is very, very fine. You know, the zinc particles are much finer than any other zinc in the world. They're like 1 micron in height, and they will migrate inside that flange. So go around with your brush and get all that worked in first, and then you can coat the outside and then the faces of the flanges afterwards. But always seal that joint first. Understand that?
Yeah.
Yeah.
Thank you.
It's a pleasure.
Let's go through the joints again.
Sorry, Kingsman?
Let's go through the joints again.
The joint. You want to see it again? Let me just see if I don't have a picture here.
Elaborate on it.
Okay, here's one. This is the flat joint. It's the same thing. You can see this bolted joint. Okay, this is not on your project, but it's typical of bolted joints. Okay, this gap you can see is very wide. It looks about 6 millimeter, but normally it's 1 millimeter, or maybe even less. But either way, you angled your blast nozzle inside that crack between the two flanges, and then you blast from side to side as you're going along. So you're putting a profile on everything within that joint. And when you've done that, then do the outside of it, and then you do the other faces. But do that first, and then seal that first with a brush, ramming the Zinga into that crack all the way down, and fill it with Zinga, and it'll go in and take it in. And even when it's still wet, it doesn't matter. Then you go outside, and then you start doing all the rest, whether you're spraying or brushing, whatever. But always do the cracks first and get them filled. Because if you do the sides first and the Zinga dries, it might stop more zinc going in. So do them first and make sure they're well sealed with zinc. Then do the outside, and that'll just melt. The outside Zinga will then melt into the Zinga you've already put there. It just all flows together. So you have a completely galvanized joint. It's physically impossible to have corrosion. Physically impossible.
When you sample, or you do a sample, because maybe keep inside, maybe when the metal is rusted, you don't need, like, maybe spend much time. Yes,
the holes are not too much large. But what you're talking about, I think the hole is too much large.
Then you need to replace the area.
I'm just trying to find another.
Ask me, sorry, is it there? Yeah.
Save this on there.
You make such a thing, the more you are trying to blast it. But some of the particle goes into it. Mostly the corrosion is not enough out. Inside is that is when you use a hammer. You have to be careful. In between the metal and see that most of the times
Get this damn thing here.
that's one to cover brush.
You have to make sure the cement and everything is clear and everything is clean.
You have to make sure no dust.
Yeah, exactly. Yeah. For example, I think that when even for on the ground and the kind of fix it. Yeah, right. You breathe away.
Once they are for that's impure.
This is a sample.
Can you see that drawing on the screen?
Yes.
What this is? Okay, this is a very exaggerated drawing. Okay, because normally on a bolted joint you won't have such a big gap. But this goes to show you what happens if you don't have Zinga in that joint. All the water goes inside. It starts eating through the bolt. And I've seen a power pylon for electricity. I saw one collapse 3 years ago. It collapsed because the bolts near the bottom were rotten because they were eaten through, and the whole thing collapsed. Luckily, it was in the country, so nobody was hurt. But this is happening. I've seen it in Tunisia and that as well, where bolted joints weren't ever treated. They were just left, and they did the outsides. And I said, you must do it inside the joint as well. That's critical, because that's what happens. It eats holes through your bolts.
Okay, Rex.
Yeah.
Yeah, in the case where the bolts are actually eaten up, then rusting has occurred in between the phalanges, right?
You what? Sorry, Kingsman, I didn't hear the last part.
Yeah, and the case where see what the bolts is, what the bolts are, the space between the two plates that the bolts are joined into. When blasting occurs over there, sometimes the bolts actually eats up. The case where the bolts are already rusted.
Well, yeah. If that happens and you can, it's best to change them if you can see that they're damaged. It's best to change the bolts and just put in brand new galvanized bolts. If you can't get them, put a normal bolt and then just blast clean them. Okay, because inside the joint it should be completely dry. So if you blast the outside, the bolt head and the nut and the exposed thread sticking out the nut, and then brush on Zinga, that should be fine.